My name is Lucas Diekmann, and I would like to talk to you about default disambiguation. Sorry? It's on. Better now? Okay. So I want to talk to you about default disambiguation and why, even though this may seem like a bad idea, in a batch-oriented parser, it can work quite well on online parsers. So wouldn't it be cool if we could take two languages, compose them together, and then we can have an editor where we can edit the resulting language of that, with the editor automatically recognizing whether we're writing in one language or the other. So this may look something like this. Is this? Oh. It's okay. Is it big enough? So let's say I have a composition of Java and SQL, and then I want to write something like this. And now I want to insert SQL, so I just type out my SQL. And then as soon as the editor recognizes that I have typed an SQL statement, it shows me this by highlighting the statement for me with this background color here. However, I wasn't done, so I just continue writing my SQL statement here. And as soon as I have expanded this, the editor again recognizes this and updates the highlighting for me. It also applies the correct syntax highlighting for both the SQL language as well as the Java language. And in the background, we also get parse trees for both languages. But let's backtrack a bit. So why do we need any of this in the first case? Well, language composition is useful for a variety of things. For example, in domain-specific languages, language composition can allow us to, instead of creating a completely new language from scratch, take the bits and pieces of languages that we like and mesh them all together, and then have a new language like that. Or in code migration, language composition can help us to gradually migrate a code base from one language to another. However, there's one big problem, one big scary challenge when it comes to language composition, and that is ambiguity. Because language composition is essentially grammar composition, whenever we compose two languages together, we are very likely to introduce ambiguities into the new language. And the more similar our two languages are, the more ambiguities we get. However, there are a few ways around this. So one approach is a delimiter-based approach, and what this essentially does is it inserts special tokens or characters around the embedded language, and that then helps the parser to detect where one language ends and the other one begins. And the good thing about this is it's quite easy to implement. However, these delimiters can be visually a bit intrusive, but more importantly, they restrict our embedded language because we're not allowed to use these delimiters within the embedded language anymore. An approach that doesn't suffer from this problem is scannerless parsing. Scannerless parsers can parse all context-free grammars, which includes ambiguous ones, which means there's no need for delimiters. However, when we parse an ambiguous program, we get a parse forest, and then we need to reduce this parse forest back to a parse tree using disambiguation operators. However, since ambiguity is generally undecidable, it's quite difficult for us to know if we have addressed all points of ambiguity or whether we have missed some. Yet another approach which doesn't suffer from any of the previous problems is syntax-directed editing. In such an editor, users directly modify and alter an abstract syntax tree, which means there's no parsing required at all. That's good for us because there's no ambiguity and we don't need any delimiters. However, these editors are very different from traditional editors, which makes them difficult to use, and it thus has been difficult to actually convince programmers to use them. Finally, another approach, incremental parsing, which is what we're using. An incremental parser parses input as the user types it out. So after every key press, we get a new, fresh, updated parse tree, and we can combine this with language boxes to embed languages. And a language box is essentially the same as the delimiter-based approach, except that the delimiters are completely invisible, which means they don't clutter our input, and they also don't restrict our embedded language. However, the big problem with language boxes is they must be inserted explicitly by the user. I can also give you an example for that. So let's say we want to do the same now with language boxes. So I type my Java, so now I want to insert SQL. So I have to press a key combination, which shows me all the language boxes that are available, which are quite a few. Luckily, the editor highlights the only language box that is currently valid in this context. So when I confirm this, it inserts a language box into my program and moves the cursor inside of it. And then I can just type my SQL. And once I'm happy with my input, I have to leave the language box again with a special key combination, and then I'm back in Java, where I can just continue typing Java. And you can see how this can become quite tedious, especially if we have to use language boxes quite frequently, or if we have multiple language boxes that are valid at the same location, in which case we need to kind of make up our mind which language box we want to insert before we can even start typing. So naturally, being programmers, we asked ourselves, can we automate this? And by this, we don't just mean inserting language boxes for the user, but also expanding them if the user changes the input, or even removing them entirely if that is necessary. However, we haven't solved ambiguity, so we kind of know that we can't always do a perfect job. We can't always perfectly anticipate what the user is intending to do. So we need to lessen our expectations a bit. So what we want to do is just about a good enough job that users may find this a useful feature over having to insert language boxes manually. And don't get it wrong, which we will, but don't get it wrong too many times that users find the feature annoying and turn it off, or just go back to manually inserting these language boxes. So the first question we need to answer is, how do we even know that a user intended to insert a language box? And our answer to this question is based on a simple assumption, which is whenever I embed one language into another, that embedding will cause a parse error. Clearly, this is not always the case, but it happens frequently enough to give us a good starting point. So here's an example for this. We have embedded SQL into Java, which has caused a parse error on this name token here. And this triggers our algorithm. So what we do next is we scan the program backwards to find all locations at which we can validly insert a language box. So there may be multiple locations. There may only be one or zero. In this example, we can find such a location just after the return, because the composition we're using here allows us to embed SQL languages wherever Java expressions are valid. So for all the locations that we find, all the locations where a language box would be valid, we then create a parser for the embedded language and then pass the input from that location forwards. And every time that parser finds a program that is entirely valid in the embedded language, it generates a candidate. And then it continues parsing because there may be bigger candidates to be found. And once the parser encounters a parse error, then we know there are no more candidates to be found, and then we stop. So at that point, we will have created a list of candidates, and if we've only found a single candidate, then we can immediately insert this candidate for the user by just wrapping the text that we found inside the language box. If we have found multiple candidates, then we will have to present them in some way to the user so they can select the one that they intended from a list. Yes. So the problem is that in order to find these start locations where we want to insert a box, we can't just scan our entire input and try every single location, because A, that would be too slow, and B, we may produce way too many candidates that would simply overwhelm the users with options. So instead, we have created 3 heuristics which scan our input in different ways. So the first one is the parse tree heuristic, and that one simply takes the current parse tree of our program and starts from the error location, which is this one here. It walks upwards to the tree, and every parent it finds on the way, it tries to insert a language box just before that. The stack heuristic does something similar. just on the stack, so it takes the stack at the time the error was found, and then for each location on the stack, here it checks whether a language box can be inserted in that state. And then finally, the line heuristic, which is probably the most intuitive of the three, starts at the error location here, and then it just goes backwards, and for each preceding token, it checks if a language box can be inserted in between. And because we have to limit our search space, we stop at the beginning of the line. And because these heuristics scan the program in different ways, they obviously have different strengths and weaknesses. So we take all the candidates they find, combine them to a list, filter out all the duplicates, and then we rank the remaining candidates. And how the ranking works is we take each candidate and then we apply it to our input. So we virtually insert the language box that this candidate represents into our program and see how far does this allow us to pass past our pass error, our initial pass error. And then we throw away all the ones that can't pass as far as any of the others. And typically at this stage, we only have a couple, maybe a handful of candidates left. So I can give you another example of how this works in action. So let's say I have Java and SQL again, and I want to replace this one here with a language box, SQL. So I just start typing something like this. So in this case, the editor has now found multiple candidates, which means it couldn't insert a candidate for us. So instead, it gives us this light bulb icon here on the left, which shows all the candidates that we have found. And then the user needs to select one from the list. I'm just going to pick this one. And then the language box gets inserted into our program. Here's another example that shows the removal of language boxes again. So if we have this program here with these quite terribly named variables, then we can do it. So now we want to combine and multiply all these variables together, and you can probably see where this is going. So the user has forgotten one of the multiplication symbols, and the editor has recognized this as a, sorry, actually, I wanted to make this lowercase, but it doesn't matter. Oh, but it doesn't matter too much. I may have broken this now. I'm going to try this. I might have broken it, but I'll explain this after. So the user has forgotten this, so the editor has recognized this as a select, as a SQL statement, and entered a box. This was clearly not what the user intended. So instead of forcing the user to manually remove the box, we just let the user fix their mistakes as they normally would by inserting this multiplication symbol here. And then it automatically removes the box again because that's the only way to make sense of this program and make it pass. So we then try to see how well these heuristics work in practice. And for this, we created a bunch of compositions using the languages of Java, Lua, PHP, and SQL, and ran randomized tests for each permutation of these languages. So the following shows how such a test looks like on the example of Java and PHP. So what we first do is we load our editor up with the composition, so in this case Java and PHP, and then we load a Java program, and then within this Java program we try and find an expression here, this, and we delete it. A random expression, and then we delete it, and then we replace this expression with a random PHP expression down here, which we type one character at a time, just like a user would do. And then we check whether or not a language box was inserted. And we do the same with, not just with expressions, we also do this with functions. So where, for example, replace an entire Java function with a PHP function. And the basis for all these programs and expressions and functions were extracted from real-world programs. For example, for Java, we used the Java Standard Library. For PHP, we used WordPress. So this is now the evaluation. And this one shows all the percentage of the acceptable outcomes for each heuristic down here. for each composition. And so we can see, even though we have sometimes some of the heuristics don't work as well as they could or as the others, if we look over here, of the 5,000 tests roughly that we ran, about 97% have an acceptable outcome. However, what do we mean by acceptable outcome? So there's 6 different categories of what could happen if we try to insert an embedded language into an outer language. So the first one is the one that we like to see the most, and that's an acceptable outcome. And that means we have wrapped the entire fragment that we inserted inside of a language box. And at 66%, that's a decent result. The next one is, sorry, let me move this mouse. The next one is also an acceptable outcome. However, we haven't wrapped the entire fragment inside a language box. We only wrapped parts of it. But however, the remaining bits that stayed in the outer language are still valid in the outer language, which means choosing this to fix the initial parse error that we had doesn't cause any new errors. So it's still an acceptable way to fix our parse error. The next one is an unacceptable outcome, and this basically means that we have inserted a wrong language box, which either hasn't fixed the original error or has introduced new errors. So that's what we like to see the most. Lucky we do at 2.3%. However, we still could improve this number. It's still not great, but it's not terrible either. Then we have no insertion with a valid program. So that basically means we have inserted a fragment which was already valid in the outer language, which means we didn't trigger a parse error. So there's nothing, our heuristics didn't trigger, there's nothing we can do. So we treat this also as an acceptable income. An example for this would be I insert the Lua x+1 into Java, which Java can also parse. So there's nothing we can do about that. Then we have, second last, we have no insertions with errors, and that means we have inserted a fragment which has caused a parse error. However, we were unable to find a good location at where to insert a language box. So our heuristics failed to detect something here. And luckily, at 0.8%, this is not too bad. And lastly, we have another acceptable outcome, which is we have found multiple candidates. And in this case, we just have to ask the user for help, and there's also not much we can do. We can't automatically insert anything for them. Then finally, let me quickly give you an example for where these heuristics don't work that well. So this one is an example for the parse heuristic, and we can find this when we compose Java and PHP, and we insert some PHP expression inside an if condition. And because the parse heuristic only checks the parents of the parse tree, we won't be able to find the location just in between these tokens here, just after the lpar token, which is the only valid point at which we can insert a language box. The stack heuristic also has a weakness, and we can find this in Lua and SQL compositions. And the reason for that is that the Lua parser sometimes reduces things a bit too early. So by the time we reach the error, which happens on the from token here, the parser will have already reduced this x equals select to this parse subtree here and push that onto the stack, which means just by looking at the stack to find locations at where to insert language box, we will never find this location here just before the select, which is the only location to fix this error up here by inserting a box. And lastly, the line heuristic also has a weakness, and we can find this in Java and PHP again, but this time when we try to embed a PHP function into a Java function. And that is because the PHP function headers look very much like a Java method header, where Java just interprets the function keyword as the type of the function. And that means whenever we insert something like this, the error that we eventually get is one of the following lines. However, since line heuristic stops at the beginning of the line, it will never be able to find this position here just before function in order to insert a box. And that's it for me. Thank you very much for listening, and I'm happy to answer any questions.
Thank you very much. like a special round of applause for trying to do a live demonstration in front of everybody.
Thank you.
Brave. Questions?
What is the editor that you showed?
So that's the editor that we developed in order to make language boxes and this technology as well.
It does incremental parsing.
It does incremental parsing in the background, yes.
Can we try it on your...
Do you
play with it on your website?
You can find it on GitHub, yes. But mind that it's a prototype, so there may be bugs, but let me know if there are, and I'm happy to help out.
Lucas, that looks very cool. I'm trying to understand what is going on. So you're saying you automatically detect delimiters between boxes, in a sense, right? I mean, it's kind of language box delimiter inference. Is that?
I have not delimit. So the delimiters are kind of there are no delimiters. I've detected. I've used. So the short description of this will be we're using parse errors to find locations where the user has tried to embed another language. And so the locality of the parse error helps us to restrict our search space. So we only search around the error to find something that looks like an embedded language, and then if we can find something.
But with language boxes, you're switching from one parser to another. Right? Is that for?
Yes. Yes, the language boxes are parsed. The outer language and the language box languages are parsed by different parsers. However, when let me just go back to this here. So whenever we find, this one is on here as well, sorry. Whenever we find like a parse error, then we first try to find any location in the outer language where we have set, we allow language boxes at this location, which is just after this return here. And then we use a parser in the embedded language to pass the input that follows. And if we can pass this in the parser for the embedded language, we find some fragment that is valid, then we know we can now insert a language box for that.
Right. And your parsers are deterministic and therefore
Yes.
suffer ambiguity within the fragments? But
Well, we still have ambiguity, so we still...
But your examples at the end suggested that you do still get ambiguities, right?
Yes, we do. No, we have not solved ambiguity, and we won't be able to. So, so this only works because if we make a mistake, which we inevitably will and do, the users can just revert this. So the challenge is more like, can we keep these mistakes to a very low minimum where the users don't mind running into them every once in a while, and that the benefits of having most of the time the correct language box inserted for you outweigh this negative.
Right, but now in a sense you're simulating a generalized parser, aren't you? Because you're exploring different possible parsers.
Yes, sort of, but I can if I get it wrong, then the user can intervene and change things, which I think in generalized parser, if I make a wrong decision, then I keep that decision for the rest of the pass, right?
If you do error recovery, I mean, you could explore multiple. I mean, essentially, you're exploring multiple possible branches in parsing, and you're getting all possible results, right?
Sort of, yeah. So if I only find one, then I know then I can insert the language box for them, so I know there's only one solution, so I'm very confident this is the right one. But if there are multiple ones, I can still ask the user to disambiguate my input. So if I really don't know, I can ask the user. If I find multiple ways in which I can pass something, I can tell the user, well, here's a list of all the options I found, and then you choose the one that you intended because I don't know.
So this is kind of Eclipse Java suggestion territory rather than automatic.
So we did some work at some point, exactly do this kind of disambiguation, interactive
Yes.
disambiguation of quotations.
Yes.
Maybe we should take this offline.
Sure.
Comparison.
Any more questions for Lucas? Yes, over there.
So just to make sure I'm understanding this correctly, so is the files that you create, the code you create with this editor, is what's actually being saved containing this like language box metadata, some representation that's more than just the
At the moment, we're saving parse trees. So we have intermixed parse trees. So the outer language has a parse tree, which has within, so the language box is basically a token in the outer language, and the parser for the outer language just treats this as just a normal token. But inside the token is another parse tree, which has the contents of the language box. And so it's just intermixed parse trees, and we just store them as parse trees on the disk.
Okay.
Do you treat nested cases? So do you have cases where language A calls B, and then from B you go back to A, or it's a black box for A when it sees the new language?
So we can embed, so language boxes can be embedded arbitrarily deep. However, this automatic detection, so if I'm within my second language box and then I type something that can be interpreted as a third language box, that would work. However, if we like two at the same time, we haven't really looked into that yet. I'm not entirely sure how well that would work in practice.
Okay.
Eric had another question.
Eric's waving at me. Eric.
This is a question about your assumptions. Are you telling me that the highlighting that we see here is less intrusive than delivered?
I had a feeling you might say something like that. Well, I can. Oh, sorry.
It's okay to just say yes.
No. I can also just. I can turn it off if you want.
Yeah, that's much
But
I'm not sure which is better or worse. I mean, to some extent, you like some indication that.
I guess that's personal taste.
I have another question, but we'll take that.
Okay.